Right, hello and welcome back to another video. So this week we're going to be looking at another question that was sent in by one of the viewers, and it was based on this image here. How can we create a nice gradient for these trees to allow us to do this sort of darkening at the bottom? And we're going to look at four-ish different ways of doing this, all of which have different pros and cons. Different features that you might want to use, and I'm not going to use a tree model. I'm going to use a nice simplified cylinder, but all of these things can be applied to any model that you want to do. So the first way we're going to solve this problem is by using world coordinates. So I have here a few cylinders. These ones are obviously higher up, and the gradient I've used blue and red, but obviously you can use whatever gradient you want, and it's all based around world height. And so this is a really good way to do things that would be specific to a level. So if you think about making a dockyard, you might have a high water mark or a tide mark. You want that to be consistent around every object, regardless of where it is in the world. You want it to be based around the actual sort of world height, and that's what we're going to do first. So if I go over here and just create a new material, class world height. I'm just going to apply it to these objects. Details, class world height. There we go. Now I'm just going to really simplify these materials, make them a nice unlit. And there we go. Just to sort of make it nice and clear about what we're doing. But as I say, you could use this for different material types. You could sort of have brick above and wood below, or sort of darkening, or whatever it is you want to do. We're just building that mask based on sort of the world height, and then how you use that mask depends on what your project is. So in this case, I'm just going to lerp between two colours, make it nice and clear. In this case, I'll just use black and white. Color 2. Let's use two actual colours, make it nice and clear. So red and oops, missed my red. The colour and the saturation. There we go. And let's not use blue, and let's not use green. Let's use yellow. Red and yellow is quite a nice gradient. And we're just going to blend between those two. So first thing here, using a lerp, when we put an input value, let's just make a parameter. Anything we put in at 0, we're going to get pure red. Anything we put in at 1, we're going to get pure yellow. And anything halfway between the two is going to blend these two colours together. So that's going to give us our kind of gradient. And what we're using is the world position. So if I bring in the world position node, it's called world position here. It's called absolute world position there. Just a minor inconsistency. I don't think if you type in absolute, you'll find it. So just remember to type in world position. And what this does is it gives us the per pixel location of the pixel being rendered in world space. So if I just plug that straight into emissive, what we'll find is everything glows a lot. If we select this object, it's in 2,500 units in the y-axis. So that's why this is so green. That's a very big number, and this is per pixel. If I take this, duplicate that value and just stick it at 0, and if I just visibility show only selected, do this, I bring this down a little bit, you can see right here around the origin we've got some sort of decent gradients. So by using world position, we're getting these world location values. These numbers get very big very quickly. They're in Unreal units, which are centimeters, but we are getting a gradient here. We are getting values that just go up and up and up. So all we need to do is take those values and just hide that and go over here. Let's just open it up. I'm going to take those values and just divide by a big value as well. So I'm going to call this gradient scale. And effectively what this is going to do is let us take the, excuse me, big value, 1024. Let us take where we've got 0 and where we've got 1 and just move it, and just change it. So in this case, now our values are much more reasonable. It's still very green, still very glowy, because the value in green is much higher, but they're a bit more manageable values. If I go back in here, I'm just going to do a gradient in Z for now. we're using world height to do this, and so the world position, if I mask out the blue value, that's going to be the sort of the height component, or the blue axis, the Z axis. There might be effects you want to make that are based on red or green. If you had sort of a, I don't know, a shoreline with an ocean, you maybe want a sort of an effect about how far you are off that. That might work, but it's much more common to use a height-based thing. And all we need to do that is mask this out. And so yeah, so now dividing by a value, if I just apply this and have a look in the world, the black point of our gradient, our 0 point is at 0. 0 divided by anything is still going to be 0. But our white point, let's see how well this copes with this, that's being affected by this divider. So it's effectively changing, yeah, where our 0 is. If I put this down to 512, and just double check how many units this is. So if I go up to 512-ish on our Z, so this is at 0, so our gradient starts from 0 and it goes up to about 1 at 512, and it keeps going up. The gradient value doesn't just stop at this point. If we did want to always have a pure value, we could put a clamp in here, and there we go. That would give us a red to yellow gradient that then goes no further. And you can see red at the bottom, but we can't really see it on these ones. If I wanted to move this gradient up, well, the divide value, or divide math, lets us change kind of like how far apart our 1 and our 0 are. Well, if we add a value in here, and let's call this gradient offset. We set that to 0, and connect it, and have a look. This is going to let us change where our sort of 0 point is. So here is 0. If I want to bring this up about halfway, if I do this, there we go. It's gone a bit too quick. Oh, the scrubbing's not the best. There we go. I need to use negative number because I'm bringing it up. That makes sense. There we are. Now you can see I'm moving kind of the 0 point. So with these two values here, I should be able to get quite a lot of variation in my gradient, changing where the sort of gradient starts from, or the 0 point, and then changing where the gradient kind of extends to, or the 1 point, and you can see I can move them up and down and get quite a lot of control. Very tight gradient, or sort of a more soft fade, and then moving it physically moving it up and down in the world. Now the last bit of control we might want to do is contrast. At the moment it's always going to be a linear gradient. It goes from 0 to 1 because that's what these values are doing. They're just linearly increasing. And if we swap this in and do a duplicate, there we go, and I'm going to call this gradient contrast, or power. Let's just call it what it is. Value of 1 does nothing for a power node. If I put some bigger values in, 2, 3, 5, 50, you can see we're pushing those values up in that gradient, and going the other way, 0.2, 0.1, we're sort of contrasting the other way. So value of 1 is a linear, and then sort of 2 or 3. So just giving ourselves a bit more control if we need to. Do be aware that powering is a slightly more expensive command or instruction. So if you are using it, make sure that you are using it. Make sure it's worth the use. You don't just include it automatically. But these are very sort of basic and cheap instructions. And that would work. That works for a gradient. Obviously, I say we could do a tree bark and then a darker multiply color, anything like that, up in the rest of our shader. And this is all based around world position, so whereabouts in the height you are, which would work really well for tide marks, anything like that that's going to be consistent across multiple objects at a certain point in the world height. Cool, that's our first one done. So, second example, well, here we've got two columns at different heights, and the gradient is always in the middle. And so rather than being a world gradient, this is what I would call a local gradient. it's relative to where the object is, and it's very easy to convert from that one to the other, as it just stalls for a second. Updated recently to 5.03, does seem to be a little bit stuttery in terms of performance, but we'll just give it a second, finish thinking. The encoding might not be helping, but there we go. So if I just take that material, let's do it in this screen. So tutorial files, tree gradient. If I take my class world height, I'm just going to duplicate. I'm going to class and call this object height. And this is going to create a gradient that is specific to there we go, class object height. That is specific to the object itself. So rather than being a gradient that's consistent across lots of objects, each one is going to have their own height. And there we are. The norm we need to do, if we take our world position, well, as well as world position, which is the per pixel position in world space, we also have this node here, object position, and this is not the pivot points position, but it's the position in world space of the center of the bounding box. So every object has a bounding box around it, and the center of that, so it's this point here in the middle of our object. Could use the pivot, that's also something we've got access to, doesn't really matter. But what we want is a value that's consistent across the object, and that's what object position is. So if I just take those two values, and if I subtract one from the other, and I might just mask out the blue channels first. So we take the world height and the object height, and then I subtract one from the other. We're just moving that gradient so that it's always going to be local to our object. Just reset my offset, and let's set the scale to be, let's say, I don't know, 1 to 8 for now, and the power back to 1, just put some nice defaults in, and all we're doing, is taking the position of the object, kind of rebasing that world gradient. So we're still going from 0 up to infinity and down to negative infinity, but now we're doing it by recentering to that object. And as we see, it can move up and down still. Same logic applies. It's a bit stuttery. We can change the scale. Yeah, this used to work better in 4. Hopefully this is something they're going to work with. If you make an instance out of this, you can sort of scrub these values a lot better. But as you can see, very low values will get a very hard line gradient. Very high values will start to get a more sort of softer gradient, and then obviously we can control the contrast as well, so changing that fall off between our two values. Cool, this works really well. It's a gradient specific to the object at a certain height, based around that center, but what happens if we were to, say, take this object and paint it as foliage? So if I get my editor back in a second. Yeah, it's very stuttery. Give it a second. There we go. These here are the same cylinders. I've just painted them using the foliage paint tool, and as such they are painted here. If I put this back to the class one we've just made, class object height, there's a problem. As painted foliage, it's using the bounding box of the whole foliage group as opposed to each individual foliage. So we're getting a result a bit more like this one, where everything's at a certain height, but it's not. If I move this up, can I move the foliage as a thing? Doesn't seem so. Okay. But anyway, it's doing it at a certain height. If I want that to be more like this result, we put the object position shader on that. We need to make a very small change to this, and if I just open it up here, what we're going to do is we're going to pass the information through the vertex interpolator. If you want to know more about that, I have made a video on it in the past, so you can go and check that out. But basically what we're doing is we're telling the shader to do the calculations per vertex instead of per pixel. And because of the way this works, the object position when you're calculating it per vertex gives us the instance position instead of the sort of the overall object or the overall foliage position. So having put that in, if I just click apply, what we should get now is each one of these has the object gradient sort of per object. Maybe I'll just bring that up. A bit easier to see. And there we are. So halfway up, or whoops, close the whole thing. About halfway up is the gradient for each of these. So if we're painting it as foliage, no problem, we can still use the same thing. We just need to make sure that we're using the object position through the vertex interpolator to get the per instance position, and you can get your halfway up. One other node that's worth looking at is this one here. This is the object position or object box based UVW 0 to 1. This is one of the functions that comes with the engine. UVW, we'll find it. There it is. Object box, bounding box based 0 to 1 UVW. If we just open that up, it's doing a very similar thing to what we've just done. So it's taking the world position and the object bounds and working out sizes and scales, and you can get the sort of local position gradient for the object. So I've got it here applied to this box. You can see we have a gradient at the bottom, and if I rotate this, it stays kind of local to that. So another sort of inbuilt way of getting kind of gradients for an object. Cool. Last one. Well, a bit of a problem. What we've done so far is all sort of object and location based, which is great, but not if things animate or if things have to move. And so what we can also do is actually just map our object in another way. So this is a slightly more expensive way to do this, but gives us a lot more control, a lot more power over it. So I have here the mannequin. This is a static mesh that I've made as a copy just so I can access the UVs. And what I've done is I've just exported it into Maya and created another UV set. So by default, the model comes with UV0, which is its sort of diffuse texture. Then it has UV1, which is the light map UVs, which have been generated. There's a few errors in this one, but we'll ignore those for now. And then finally, there's also UV2, which is the one I've created. So I've just done a planar map from the front, and you can see how you get your kind of character laid out exactly how you want. So in this case, we can take this and apply a gradient to it. And all I've done in the shader, if it opens up, it's used UV2. So to access those UVs, UV1, or say UV0, so the diffuse color, the gradient for that, we can see, oops, let's go back to this guy, and then right here, this is the gradient applied to those UVs. If I open up the material again, maybe side by side these, if I do UV1, this was the light map UVs, and apply those, you'll see everything's a bit gradients all over the place, but gradient 2, and there we are. And what's nice about this is if I put this on a deforming model, obviously we're just mapping this in UV space, not with world space, so this will deform nicely. The hands will also be the same, always be the same color. It's quite common in sort of top-down games to do this, probably the invert of what we've got there. If I just 1- it, just to artificially make the top of characters a little bit easier to see. You could see that, but then as the character moves around, no matter how high it is, whether it jumps, whether it falls over, anything like that, it's always going to be darker at the feet and brighter at the head. To actually create those, it's very simple. We'll just do a simple object, say a cube. In Maya at least, I'm sure Blender can deal with these, or Max, or whatever your sort of 3D modeling package of choice is. Obviously we come with default UVs, but we also come with this option here, UV set editor. It's this one here. and there's nothing stopping us just creating new UV sets. By default, when you create a new one, it's empty, so there's no UVs here. But I could do, let's say, a planar from the front, and there we are. Let's maybe use a slightly more interesting object than a cube. Let's try that sphere. There's our default sawtooth UVs laid out decently. Get a little bit of stretching and seam at the top, these kinds of things. But we could also go in, do a new UV set, and let's do that from the planar from the front. And there you are. We've got another unwrap. There is a cost to this. Having multiple UV sets does add up. So you don't want to just use them wherever, or where you add them, make sure you are using them. But at the same time, it's a very convenient way to be able to access another part of the model, or another way of texturing the model. So you can have one UV set for sort of a diffuse tiling texture, one UV set for a gradient top to bottom, another UV set for some other sort of V effect. If you've got kind of like a character burning or something like that, or a dissolve, you might want to dissolve them out from a certain place. You can do it in world space, you can do it in local space, you could also do it with a unique UV unwrap as well. So lots of ways to control creating gradients across things. Cool, hope that was helpful. As always, thanks to all the questions and Patreon supporters. If you do have your own questions, please feel free to email in. I'm always happy to answer, and if anything becomes really interesting, might do a video about it. But until then, yeah, I'll see you all next time.